So we're picking up on some climate literacy material for our one of our final quizzes of the quarter. So when we try to infer about Earth's past, what the climate was like previously, we rely on SIT. Evidence in the sediment, evidence in the ice, and evidence in tree ring data. Sediment, ice, and trees. So in the sediment, you can find ancient pollen samples, when there were major catastrophes, and check out isotope ratios. We'll explain a little bit more about that in a second. Within the ice, we know there's bubbles of ancient atmosphere in there. It gives dust pattern debris information. And again, types of pollen are available in that, carried in the air. And then isotopes there as well. And finally, trees. Growth rings in trees, the pattern shifts based on what the climate is like. And so analyzing trees that we've monitored in real time and what those growth rings look like, and you compare them to ancient ones, you can make inferences about past climate. For example, looking at trees. These two pictures show the bottom sides of the same kind of leaf. And here are examples of stomata, little openings on the bottoms of the leaves. And in this one, the stomata are closer together. And this one, they're further apart. So the low stomata density means higher concentrations of carbon dioxide. Because trees are only going to have as many stomata as they need. So there were past times where CO2 levels were even higher on Earth. Well before, like thinking back to the dinosaur times, for example. And it was much, much warmer then. We can learn from the oceans. So did you know coral also has growth rings? And the coral growth rings give us clues to sea level changes. During bountiful years and scarcity years, as far as nutrients go, the coral growth rings would vary just like tree rings would. Less growth, less resources. So you can kind of analyze this diagram here and understand that when the sea level changes, the coral can't grow upward and out of the water, it can only go sideways. And if the sea level drops more, again, the coral can only grow sideways and it can't grow upward any further. So the pattern of this growth gives us a clue as to changes in sea level. This diagram is looking at isotope data. And isotopes are, again, elements that are either lighter or heavier depending on if they have more neutrons in the atoms. So change in the number of neutrons in an atom that's by definition what an isotope is. Oxygen 16 versus oxygen 18. So this one has 2 more neutrons, it means it's heavier. So heavier atoms would have a harder time evaporating. But the warmer it is, the more chance that you can get the the heavy isotope in the atmosphere. So in today's atmosphere, oxygen is 16 to 98.6% of a sample of oxygen, and you find the proportion of oxygen in water. Higher proportion of oxygen 18 in fossil shells indicates a cooler climate. So it's not going to get in the atmosphere, it's going to be staying in water. So higher concentrations of oxygen 18 in polar ice indicate a warmer climate, because the oxygen gas got locked in those bubbles of ice. And it's because oxygen 16 evaporates more easily. So if you are more curious about isotopes, you'll learn more about that in chemistry. Looking at tree ring data, that's called dendrochronology. Wide growth rings mean optimal moisture during the growing season, whereas narrow rings mean stress and lack of moisture, maybe cold or too hot. And you can estimate back 10,000 to 60,000 years back. Now, you might wonder, how is that possible, considering the oldest tree isn't that old? But this diagram gives you a clue. So we look at this diagram to understand that if there's a living tree, you cut it down, you know exactly when you cut it down, what year it is, trace back the growth rings to when it was planted. That gives you a timeline. And then a beam that came from an old occupied house, if you were to get a sample or core of that and look at its pattern, you could match up the growth ring patterns of that tree with the living tree that you just had. And then a beam that came from an old abandoned house is going to have its own growth ring pattern, and then you match up the growth ring pattern from that older beam, and then you see where they overlap in common, and then you can trace back. So they take the oldest living trees and nearby rotted dead trees, and of course we've looked at the Keeling curve shown here to show a steady rise in carbon dioxide, and we can identify that carbon dioxide as from our behaviors partially because of the nature of fossil fuels and the carbon that's in it. So carbon emitted in CO2 from fossil fuels has a little carbon-13 and no carbon-14. So again, getting back to isotope ratios, they call this the Seuss effect, and it gives a signature, chemical signature, that the CO2 that's been added to the atmosphere is coming specifically from fossil fuel burning. We also know, of course, that the temperature profile of the atmosphere, it's warming from the bottom up, which would explain why greenhouse gas additions is why our atmosphere is warming, not because the sun is getting stronger somehow. And we've shown that present day we're at 100 or 415 parts per million now, or over that. Continued evidence of today's changing climate. Minnesota. This is a hardiness zone map, and what it reveals by these colored shadings is the duration of growing season, where looking at the lowest temperature that area gets on average. And what it allows growers, farmers, gardeners to do is know where in the states can they grow certain plants. We have talked already about weather versus climate, so make sure you understand that distinction. So what's noteworthy on this particular slide is that the hardiness zones have shifted northward. And so there are regions of the state that have hardiness zones that were once in Iowa that are now in Minnesota. Some continued evidence of changing climate today would be temperature increase and the reduction of glacial ice and the ice sheets at the poles. So this just shows the change from average. So if this is what's typical, this is temperature anomalies starting from 1940 on, showing that trend of warming. Mountain glaciers, if you go and study pictures of those glaciers in time and compare them to today, they're significantly reduced. Or same time of year at the North Pole. This is an overlay showing the degree of loss in the North Pole of Arctic ice. So reduced nearly 50% from 1979. So the 1979 or 1980 to 2000 average compared to today. If you study coral in the oceans, we know that they are bleaching because oceans are warmer. When the ocean water gets too warm, it's put stress on the coral, and the relationship they have with their bacteria, or excuse me, the algae in their tissues that give them their color, and they end up breaking that relationship. So their mutualism breaks down. And bleaching events are getting longer and longer. We had this as a bell ringer, but birds are spending their winters further north because it's warmer, and that means there's available food for them. So phenologists studying migratory species know there's direct evidence of a warming climate. And that is where we will pause for today. Sorry about all the interruptions.